In this video, we'll see how to find out slope and deflection in case of a simply supported beam subjected to a point load W as shown in the figure. Now consider any section XX at a distance x from the left hand support. Now if this distance is x and this distance is a, then x minus a will be this particular distance. So from x we have to subtract a, so that we'll get the perpendicular distance between W and section XX. The first step is always to find out the beam, to find out the support reactions or beam reactions RA and RB. So here already we have written those reactions, but let us see how to find out those reactions. So apply the conditions of equilibrium over here. So the first condition of equilibrium is summation of Fy is equal to 0. Consider upward forces positive and downward forces negative. So RA and RB, they are acting in the upward direction, so they are positive, whereas W is acting in the downward direction, so it is negative. So RA plus RB minus W is equal to 0, or we can say that RA plus RB is equal to, transfer this negative W on the other side, it will become positive. So RA plus RB is equal to W. That is our first equation. Now we have to take moment. Summation of moment is equal to 0, and then we'll take moment about point A. So summation of moment is equal to 0. Clockwise moments we are considering them as positive, whereas anti-clockwise moment we are considering them as negative. Take moment about point A. So RB will produce anti-clockwise moment. So as you can see, this RB will produce anti-clockwise moment about A. So RB into L, and this W will produce clockwise moment about A. So that is positive. So minus RB into L, because this moment was negative moment. RB is creating negative anti-clockwise moment about A, so it is negative, and this W is producing clockwise moment about A, so it is positive. So W into A and RB into L, these are the moments. Now transfer this minus RBL on the other side, it will become positive. Now this L will go on this side, so it will be in the division. So we'll get the value of RB as WA by L. Now substitute this value in equation 1. So equation 1 is RA plus RB is equal to W, and from this we can easily find out the value of RA. So RA will be equal to W minus RB. Substitute the value of RB, that is WA by L. Now you can take W common from this, so it is 1 minus A by L. Cross multiply by this L over here, so L into 1, that is L minus A upon L. Now we know that L is equal to A plus B, so transfer this A on this side, so L minus A will be equal to B. So in this particular, in place of L minus A, we can easily substitute the value of B, so it is WB upon L. So in this way we have calculated the reactions RA and RB. So RA is WB by L, and RA is W, and RB is WA by L. So these are the values of support reactions or beam reactions. Now we have to use the Macular's method to find out slope and deflection. So moment about any section XX we have to find out first. So moment about any section XX is EI d2y by dx square. This is a second order differential equation of the deflection curve. Now we'll take moment about section XX. Consider all the forces which are present on the left hand side of section XX. RA will produce clockwise moment about section XX, so it is RA into X. Value of RA is WB by L, so WB by L into X. W will produce anti-clockwise moment about section XX, so it is W into X minus A. So now equating the above equations, so we can say that EI d2y by dx square is equal to moment about section XX, that is this particular term, WB by Lx minus W into X minus A. Let us call this as our equation 1. Now we'll integrate this equation with respect to x. So integration of d2y by dx square is dy by dx. So EI dy by dx will be equal to wb by L, that term as it is, wb upon L, that term as it is. Integration of x is x square by 2 plus some constant of integration we will add over here, that is C1, that is the compartment of Ra, minus w as it is. X minus a integration is x minus a bracket square upon 2. Now if you integrate again, then integration of dy by dx is y, so that will be equal to wb by 2l. Integration of x square is x cube upon 3, so wb upon l 1 upon 2, and integration of x square is x cube upon 3. Integration of c1 is c1x plus some another constant of integration, that is c2, and then you will complete this compartment minus w by 2 as it is. Integration of x minus a square, that will be x minus a bracket square bracket cube divided by 3. So it is the formula that we are using is x raised to n plus 1 upon n plus 1 divided by coefficient of x. Coefficient of x is 1. So ultimately what we'll have over here is EIY, that will be WB by 6, WB by L into x cubed by 6 plus C1x plus C2 minus W by 6 x minus a bracket cube. So 2 into 3, that is 6, that we have written over here. So this is the another equation that we are getting. So equation number 3. So second equation is that of the slope. Then third equation is that of the y, that is deflection. Now applying the boundary conditions. The boundary conditions are, first boundary condition is when x is equal to 0, y is equal to 0. Now substitute this condition in equation 3. This is the equation in the first compartment only, because x is equal to 0, and that is corresponding to this particular first compartment where the effect of Ra is felt. So EIY, in place of y substitute 0, in place of x also we have to substitute 0, and here also in place of x we have to substitute 0. So C2 will be ultimately 0 because all the terms they are now 0. So x is equal to 0 and y is equal to 0 in the first compartment only. So that will give you the value of C2, that is, this is 0, this is also 0, and this is 0. Now put x is equal to L in equation 3, x is equal to L and y is equal to 0 in equation 3. So in place of x now we have to substitute L, and in place of y we have to substitute 0. So in place of x it is L, and in place of y it is 0. So WB by L into L cube by 6 plus C1L plus 0 minus W by 6 L minus A cube. So now this is important part. So left hand side is 0. We have to find out the value of C1 in this particular case. So this is WB. Now we can cancel out one of the L term over here. So it will be L square by 6. So it is WB L square upon 6 plus C1L minus W by 6 L minus A bracket cube. Now instead of L minus A, we can substitute B. So it is W by 6 B cube, because L is equal to A plus B implies that L minus A is equal to B. So L, in place of L minus A, we can easily substitute the value of B over here. So to find out these values now, to find out the value of C1, transfer this negative term on the other side, it will become positive, and transfer this positive term on the other side, it will become negative, and that will be the value of C1L. Now we can take certain terms common over here. So suppose we take WB by 6 common, that is this particular term WB by 6 common, then here it will be only B square minus the L square term, and that is equal to C1L. So now we can easily find out the value of C1 from this. So it is B square minus, in place of L we can substitute A plus B. So that is equal to C1 L. Now it is A plus B bracket square. So it is A square plus 2AB plus B square. So this term as it is. Here it is B square minus A square plus 2AB plus B square. That is the expansion of this A plus B bracket square, and that will be equal to C1L. Now take this negative sign inside, so all the positive terms they will become negative, and you can cancel out this B square and this B square term. So it will be minus A square minus 2AB. Now you can take minus sign also common from these two terms, so we can say that it is nothing but minus W by 6. As we have taken minus sign common, it will become plus inside the bracket. Transfer this L on this side, so it will become 6L over here in the denominator. So this is the value of C1, that is minus WB by 6L into bracket A square plus 2AB. Now we can substitute these values of C1 and C2 in equations 2 and 3 to get slope and deflection, general equation of slope and deflection. So let us substitute those values. So consider the equation 2. So equation 2 is this particular. Substitute the value of C1. C1 is minus WB by 6L A square plus 2AB. The rest of the terms are as it is. Just now we are substituting the value of C1 in this particular case. So value of C1 is minus WB by 6L A square plus 2AB minus W by 2 x minus A square as it is, and this first term also as it is, that is WB by 2L into x square. Now this is the value of EI dy by dx, that is our left hand side. So from this dy by dx will be equal to, transfer this EI on this side, it will become 1 upon EI, and these terms are as it is. Now from this A square and 2AB term, take A common, so it will be A plus 2B. Call this as our first equation. So this is the equation of dy by dx, that is nothing but slope. Now we have to find out similarly the equation of deflection. So for that we have to consider equation 3. So and then in that particular equation 3 we have to substitute the values of C1 and C2. So let us substitute those values. Value of C1 is minus WAB. So let us see what is the value of C1. It is minus W. If you take A common, then it is minus W. So it is minus WB upon 6L in bracket A square plus 2AB, and then you can take A common from that particular term. So C2 value is 0 and W by 6 x minus A cube as it is. Take A common from both these terms, so it is WAB by 6L A plus 2BX minus W upon 6 x minus A cube. So this is the value of EIY. So value of y will be equal to, transfer this EI on this side, so 1 upon EI and this entire term inside the bracket. So that will give the equation of deflection, that is y. So that is our second equation. So let us write down this as our second equation. So these are the general equations from which we can find out slope and deflection at any point on the beam. So suppose we have to find out the value of slope at support, then at support, one of the support, that is at point A, x is equal to 0, and that we have to substitute only in the first compartment, because x is equal to 0, it is nothing but the equation, it is related with the compartment of RA, and compartment of RA is nothing but the first compartment. So from equation 1 we can say that dy by dx is equal to 1 upon ei wb by 2l. In place of x substitute 0 minus wab by 6l a plus 2b. This is our first compartment. So ultimately slope at this particular case will be equal to minus wab upon 6 lei into bracket a plus 2b. Similarly, to find out the slope at another support, that is at point B, x is equal to L. So we have to substitute x is equal to L in all the terms of the equation 1. Now we have to take into consideration all the compartment. For x is equal to 0, we have to take into consideration only the first compartment. So it is Wb by 2L L square minus Wab by 6L A plus 2B minus W by 2 L minus A square. So wherever x is there, we have substituted the value as L. So in equation 1. So ultimately what we are having, so L square and L, 1L will get cancelled. This term as it is, and L minus A is nothing but B. So slope at point B will be 1 upon EI, and this entire term, that is WBL by 2 minus WAB by 6L A plus 2B minus W by 2 B squared. From these two terms, we can take WB by 2 common, so it will be L minus B. So from B square, we have already taken B common, so it is L minus B. So this is the equation of support at point, slope at point B. That is the another support. Now L minus B, you can substitute for this particular term as A. The rest of the terms are as it is. So this is the value of slope at point B. Now from these two terms, we can take WAB by 2 common. So it is 1 minus. So WAB by 2 we have taken common. So instead of 6L, it will be 3L, because 3 into 2, that is 6. And A plus 2B as it is. So it is WAB upon 2 and 1 minus 1 upon 3L A plus 2B. Cross multiply by this 3L. So 3L minus A plus 2B whole divided by 3L. So this is our part of the simplification. Otherwise, you can keep this term as it is. Correct? Dy by dx you can find out up to this step itself. But we are simplifying further to get some find equation over here, or a refined equation. Take minus sign inside. So minus A minus 2B. So 3L minus A minus 2B. Rest of the terms are as it is. Now in place of L, we can substitute A plus B. So in place of L, it is A plus B, and the rest of the terms are as it is. Multiply by 3 inside the bracket, so it is 3A plus 3B minus A minus 2B divided by 3L. So 3A minus A, that is 2A, and 3B minus 2B, that is B. So we can say that this is 3A minus A, that is 2A, and 3B minus 2B, that is B. So ultimately it is WAB upon 2 into 3, that is 6EIL. So that will be the value of slope at another support B. Correct? So dy by dx at B. So WAB upon 6EIL and 2A plus B as it is. Now further we have to find out what will be the value of deflection under load. So put x is equal to A, because load is acting at a distance of x is equal to A. But we have to substitute this in equation of the deflection, that is equation 2. So deflection equation already which we have derived is written over here. So let us see what is that equation. So here, that is the second equation. In this equation, we have to substitute x is equal to A. Wherever x is there, we have to substitute value of x is equal to A, and then we'll get the value of y at that particular point. So let us substitute that value. So in place of x, we have to substitute A, so that we'll get the deflection at that particular point, that is y at x is equal to A. Now here it is A minus A, so this term will vanish. So only two terms we have to consider. So let us consider those particular terms. So WB x cubed by 6L So as we have just now seen, in place of x, if you substitute a, then this third term will vanish. So in place of x, we are having a. So this is the value of deflection under load, that is 1 upon EI. In place of x, we have substituted a over here. So it is WB a cube 6L into a cube minus WAB upon 6L. So this a into a, you can see that this is a square, or you can keep it as it is. So it is WAB by 6L, a plus 2b into a. Now what we'll do, we'll take a square common from this term along with WB by 6L. So W a square B by 6L we will take common. So it will be only a over here in the first case and only a plus 2b in the another bracket, because we have taken W a square B upon 6L common. Now take this negative sign inside. So 1 upon EI W a square B upon 6L, this a minus 2b. So a we can cancel out, so that it will be only minus 2b that will remain. So this is 1 upon EI W a square B upon 6L minus 2b. So if you simplify further, you'll get the final form as minus 1 upon E minus W a square B into B, that is B square, divided by 3EIL, because this is 2 upon 6, that is nothing but 3. So this is 1 and this is 3. So this is the value of Y at load or under load W. Now we have to find out the value of maximum deflection. We know that deflection is maximum when slope is 0. So dy by dx is given by this equation. Now we'll neglect this particular term, assuming that the maximum deflection takes place between A and C. So only first two terms we will take into consideration, so that our calculation will be simple. Equate this dy by dx is equal to 0. So WB by 2L into x square minus WAB upon 6L A plus 2B. Now this will be getting cancelled out with the 0, because EI into 0 is 0, and you will get the rest of the terms as it is. Now we have to find out the value of x. So transfer this negative term on this side, it will become positive. So WB by 12 x square will remain, and we have transferred this entire term, negative term, on the other side. So it is positive. So we can say that WAB upon 6L A plus 2B. This term will become a reciprocal when it comes on this side. So it is 2L upon WB. That will give the value of x square. So we can cancel out certain terms from this. So L you can cancel out. Then this W and B also you can cancel out. And 2 upon 6, that is 1 by 3. So now before we find out the value of x, we'll simplify this further. So add b square and subtract b square over here. So this first term is nothing but it is the square of a plus b bracket the square, and a plus b is nothing but what, it is L. So x square will be equal to, here it should be x square, not x cube. So x square will be equal to 1 by 3 a plus b square minus b square. So x will be equal to square root of this particular term. So this is the value of x from left hand support at which the deflection will be maximum. So we can substitute this value of square root of 1 by 3 in place of a plus b, it is L. So it is L square minus b square, or L square minus b square by 3. So this value you can substitute in equation of deflection, that is second equation. From second equation So first we'll write down the second equation and then substitute the value. So only first term we are considering, first two terms we are considering, neglecting the third term, that is the last term. And in place of x, we have to substitute the value that just now we have seen in the under term. So substitute the values now over here. Value of x is L square minus B square by 3, square root of L square minus B square by 3 and cube of that, minus WAB by 6L, A plus 2B into x, value of x is square root of L square minus B square upon 3. Now we have to simplify this particular term. So it is very typical simplification. So WB by 6L as it is. Square root of this cube term will be nothing but, so square root means 1 by 2 and cube of that particular term. So here it is WAB by 6L A plus 2B. Again square root of this term is raised to 1 by 2. So 1 by 2 into 3, that is 3 by 2. So let us write down that particular term. The rest of the terms are as it is. So we'll keep them as it is. So a raised to m raised to n is a raised to mn. So this is 3 by 2 over here. Now we'll take WB by 6L common from first and the second term. So it will be L square minus B square upon 3 raised to 3 by 2 minus, now as we have taken WB by 6L common, only A will remain. So and the remaining terms are as it is. So A into A plus 2B L square minus B square by 3 raised to 1 by 2. Now this 3 by 2 can be written as, now multiply by this A inside the bracket. So A square plus 2AB, and rest of the terms we have, for the timing we have kept them as it is. Add B square and subtract B square to this particular term. So first we'll simplify this term. Rest of the terms are as it is. And we know that this is nothing but A plus B bracket squared. And we know that A plus B is nothing but L. So substitute L in term of AB, A plus B. So it is L square minus B square and all the other terms as it is. And now the important part. We have multiplied by 3 and divided by 3 to this term. So L square minus B square, we have multiplied by 3 and divided by 3. And now if you consider these two terms, it is A raised to M, this is A raised to M into A raised to N is A raised to M plus 1. So this L square minus B square upon 3 is nothing but our A. M is 1 and N is 1 by 2. So this is L square minus B square upon 3 raised to 1 plus 1 by 2. That is M plus N. So, and that is nothing but what? 1 plus 1 by 2 is nothing but 3 by 2. So that is the form of this first term itself. So you can take now common. So L square minus B square raised to 3 by 2 divided by 3 raised to 3 by 2 minus 3 into L square minus B square, 1 plus 1 by 2 is 3 by 2 divided by 3 raised to 3 by 2. So take this L square minus B square raised to 3 by 2 upon 3 raised to 3 by 2 common. So it will be 1 minus 3. So ultimately it is minus 2 WB L square minus B square raised to 3 by 2 divided by, denominator will be as it is, that is 6LEI and 3 raised to 3 by 2. Now 3 raised to 3 by 2, if you want you can simplify that particular term also or keep it as it is. So it is 3 into 3 raised to 3 by 2 is nothing but 3 into 3 raised to 1 by 2. A raised to M into A raised to N is a raised to m plus n. These three as it is and ei as it is. So 3 into 3, that is 9, 3 raised to 1 by 2 ei. So this is the value of maximum deflection. 9 under root 3. We can write down 3 raised to 1 half as under root of 3 ei and a. So in this way, we can find out the value of maximum deflection. Thank you very much for watching.